Hello, class. This is Michael Burke, your instructor, obviously. We're going to talk today about a few things. We're going to have a discussion about about inventory, and we are going to then discuss the assignments for the week and the schedule that you have to follow in doing that. So this week's topic really is inventory management. We are looking at this outline for the chapter. You'll have a question about inventory for your discussion, and we're going to talk through that and then discuss the assignments for the week. So we're going to just get going into that. The inventory environment for the pharmacy is multifaceted. We have open inventory. We have open formularies versus closed formularies. An open formulary is one that has very few restrictions on it. Closed formularies are what a lot of insurance companies have. Basically, it means we don't pay for everything. And an open inventory means that or an open formulary is that all drugs are covered. Some pharmacies will have a semi-closed inventory in that there are or formulary in that they won't carry certain drugs. Therapeutic equivalents are drugs that do the same thing, no matter whether they are different chemical entities or just different formulations. Therapeutic equivalents, and that's kind of substitution is allowed in some states. Government regulations, well, government regulates everything, but in the pharmacy, we have FDA regulations, we have DEA regulations, we have OSHA regulations, we have all sorts of regulations that we have to abide by. Clearly, the government tells us what we can sell in terms of drugs. Drug manufacturers also have a say in this because they are the ones who actually are preparing the drugs, and occasionally we have to deal with drug manufacturers, not only in terms of drug availability, sometimes we run out of stock, but also in terms of returns. But we don't buy directly from drug manufacturers. Drug manufacturers supply local wholesalers. We have wholesalers that can be local in terms of they're in one city. They can be regional or they can be national. There are about 250 or 300 wholesalers. That number changes with consolidation and so forth, but we have about that many nationwide, and some of them are actually national versus local or regional. So they're the ones that we actually order drugs from. A couple of concepts for inventory that I want to address. The concept of turnover has to do with how often we rotate new stock into our facility. Most pharmacies try to maintain a supply of drugs, of every drug that they have, that will last approximately 30 days. So the turnover rate then would be 12 times per year. This obviously is not going to work for every product, as it depends on people getting sick. It depends on people requiring drugs. And we have drugs that are fast versus slow movers. Obviously, during cold and flu season, we have those kinds of drugs we go through very, very rapidly. During other times of the year, they'll slow down. There are other drugs that we sell very little of at any one time. And so we want to adjust our inventory to provide for those. Availability is an issue. Sometimes drugs are not available because they're not, there are manufacturing issues. We hear about shortages all the time in terms of manufacturing. And this happens because the manufacturing facilities run into problems. Other times, drugs need to be restricted availability. This is not just your behind-the-counter drugs, but this is drugs like, say, Accutane, where the availability is based on the willingness of the patient to sign certain agreements. In terms of Accutane, they have to sign an agreement that they will not, A, become pregnant if they're female, and if they're sexually active, will be using two forms of birth control, one of which should be a barrier method and the other chemical. If you're a male, you also agree that you will not impregnate anyone. And so if you are sexually active as a male, you will always be using condoms and making sure that your partner has um, uh, has at least one form of birth control that she's using. Spoilage in the pharmacy is a little different than in, say, a grocery store. Spoilage means based on the dating of the product. Pharmaceutical products generally don't go off as you might expect something like tomatoes to do in the grocery store. But what they do is become outdated. The FDA, we've talked about this, puts a 5-year expiration date maximum on a product. This is all scientifically determined. We cannot dispense drugs to patients that that we can think that that the drug will be past expiration by the time they take it. So these are generally returned, but occasionally they're not returnable for various reasons, in which case we have to have a disposal system. We have biohazard bags that we put them in, and containers. There are medical waste disposal contractors in the area that will take care of taking this material and making certain it is disposed of according to regulations. Various tools. We have point of sale systems that track our inventory basically by subtracting every time a prescription goes in the system, it subtracts it from our inventory. We have order entry devices. These are often computers, but also we can use barcodes to scan bottles and that sort of thing. We have reorder points established. In other words, we want our inventory to be enhanced when the level of stock gets below certain areas, and we can generate automated reports to do exactly tell us where our inventory is at any one time. This is all computerized, of course, and so we need to make certain that our systems are maintained and properly cared for instead of down. We also that our databases are up to date. We also supplement this with manual checking. There are automated dispensing systems that people use. These include machines that will allow us to load in specific dose by dose, unit doses for drugs by patients, or they are systems that can dispense large amounts of drugs. There are automated and robotic systems that we can use. These are expensive, so we use them for high volume drugs that we have. If you have a drug that you need to count out 360 capsules, you don't want to do that by hand. We actually have machines that can that you set up. It's set up a little like what you see behind a bar, where you have bottles of liquor sitting in dispensers where you can just push a button and it automatically dispenses a shot. In this case, you dial in an amount and it automatically counts out the appropriate amount. Obviously, these are done for high volume prescriptions. Often you see these more in automated refill facilities called central fill facilities. And these can be set up on revolving carousels, and you just go to the drug that you need. So you probably won't see too many of these. For ordering, automated ordering, basically that means that we fill out forms automatically and send them off to our wholesaler. They have to be approved, obviously, by the pharmacist first. It goes to the wholesaler. Then usually the next day they'll deliver it. They'll ship it out using either FedEx or UPS. It comes with a manifest, which we immediately check to see that and compare it with the order that it's based on to see that everything that's supposed to be shipped was, or that it's noted that it's being shipped separately, which things like Schedule II controlled substances must be, or it's back ordered. Each product contains also should be shipped with a safety data sheet, an SDS. This is a requirement for shipping things in case of spillage. We keep SDSs on most of our products because if there's a problem, we need to know how to clean up. We need to know how to spill. We also need to be able to know who the manufacturer is when we need to know that, when we have a problem. Credits and returns. Credits are basically what happens if you have an outdated product that you've returned. You get a credit on your account. Usually they will simply replace the drug. But we have to fill out certain forms. Also, when we receive it, we have to take special care with things like chemotherapy drugs and controlled substances. Chemotherapy drugs are toxic. They don't care what they kill, including healthy cells, and so we handle those very carefully and store them separately and process them in a biological containment cabinet that we use, basically a special hood. Controlled substances have to be ordered separately and received separately, and for the Schedule II substances stored separately. Various forms that we have for ordering, forms for confirmation of the order, forms for shipping, forms for returns. We also have special forms for DEA when we are doing that, when we're ordering controlled substances. For stocking and storing, everything's different. Drugs come in different packaging. Often they come in bulk bottles of 1,000 or more units. This is for our dispensing because we don't dispense 1,000 of generally 1,000 of anything. Physical layout of the stock room and storage area is going to be different for your pharmacies. Some places will stock by alphabetical, strictly alphabetical. So it can be alphabetical by generic names, so that the brand names are stored with the generics, or it can be alphabetical by name, so that the brand names are stored in different places. For instance, Ritalin might be in a different spot than generic methylphenidate. Methylphenidate is what the active ingredient in Ritalin is. So what we have is the potential for storage in a couple of different places. It depends on your pharmacy. Some stock is isolated or it's on consignment, which means we need to be careful about how we store and stock those things. Consignment stock is basically when you get something and you pay for it when you sell it. Some places will do this with what's called Plan 340B products. 340B is a federal program that requires certain manufacturers that are participating in it to provide drug at a deep discount for things like Medicaid patients and other special categories of patients. Some drugs require refrigeration. Those things obviously should come in special packaging that can keep them at a cool temperature during shipping, and should be immediately put into a refrigerator. This includes things like insulin and certain other products that we keep under refrigeration at all times. You'll rarely see anything that needs to be frozen. Point of use stations basically are, we store things sometimes in places where they're going to be used. This would apply to things like our DME, durable medical equipment, and other supplies are stored in places where the consumer can pick them up. Or if you're working in a clinic that has a pharmacy associated with it, you may be stocking things in exam rooms that are commonly used in small medical procedures. Controlled substances are stored separately with Schedule II substances under lock and key at all times. That's what I want to say about inventory. You can read the text. If you have questions you want to ask, send them to me by email. I'll either address them in the next couple of days or we'll talk about it in class on Wednesday. The assignments for the week include a discussion, your transcription group E, computer exercises, your video, which is virtual pharmacy externship, and then assessment 3. We'll talk about these in turn. The discussion this week, discussion 3, is about inventory in the pharmacy and the range of materials that we retain. This is not just things that we sell, but you need to look at everything that goes into putting together a prescription. This is not just the drug. So think about the things that you need. Not only that, but think about what you need to do in order to print instructions to the patient. So think about what you get when you get a prescription. All of that stuff is inventory, not just the drugs. So I want you to think about that particular question in some detail. Assessment 3 is a compounding assessment that'll be submitted as a quiz. It shows as a quiz in there. This is one that you'll have to actually create a Word document and upload it. This is something that I'll have to hand grade, so you won't see a grade posted immediately. It's passworded, and you'll find that password later on in this presentation. It needs to be done before class begins on Wednesday. So for the morning class on Wednesday, that means before 8:30. For the evening class, that means before 6 p.m. So be aware that that assessment is due early. The computer exercise for this week are all 3 compounding. Lab 13 is an IV prep of an antibiotic. So you'll be actually detailing the components of that when you put this together. Why do we keep a compounding record? Because if anything goes wrong, we need to show that the pharmacy has done everything according to procedure. If there's a problem with the product. The second lab is a total parenteral nutrition prep, and we'll talk about that in some detail. The third is a chemotherapy for cancer prep, and we'll talk about that in a bit too. You'll have to do some calculations. I want you to go back to the basic formula, which is D times V over H, where D is the amount prescribed. It comes off the prescription, the med order, the TPN order, or the chemo order. It's all there, and it's written down. All we have to do is read it and plug it in. V is the vehicle. This is going to be probably a volume in milliliters in these labs in all cases. And H is the amount of drug in that volume. This comes off the package label, and we'll show you an example of that in a bit. Let's take a look first at page 107 of the handout that I gave you. And 107 is a typical TPN order. It's called a quick challenge. You are not doing the quick challenge, so don't worry about that. So you see this, I've got here the top part of page 107, and I'd like to just address each section. First off, we have a patient name and date of birth. We have a height and weight. We have a next question here is basically the setup for this. Does the patient have a central line in place? What's a central line? We call it a PICC, peripherally inserted central catheter. You've probably heard PICC line in the past. Type Groshong is just a design of that catheter, named after the inventor. So we also want to know when that was actually put into place. So the next section here talks about the base formula and the infusion schedule. TPN is always prepared in 1 liter bags, always delivered at 83 milliliters per hour, which basically means that the entire bag is infused over 12 hours. So patients will actually, that are on TPN, will actually have 2 of these every day. So each bag is set up specifically for the patient. Base formula is a mixture of dextrose, which is a carbohydrate, a sugar, and amino acid mixtures. There are a lot of these things. Dextrose comes in numerous formulations, all the way up to 70% dextrose solution in water for injection. We can have either a standard base, which is 20% dextrose and 4.25% amino acids, which basically means we're going to mix equal amounts of D40W, 40% dextrose in water, and an 8.5% solution of amino acids, which is what this aminosin down here is. Or it can be individualized. In this particular order, we've got dextrose 70%. We're going to use 400 milliliters of it, and 10% amino acid solution. We're going to use 500 milliliters of it. The 10% amino acid is this Travasol. That is a trade name for a 10% amino acid preparation. We also have aminosin 2. There was an aminosin 1, but most people don't use that anymore. And Freamine we have down here. That was a product that was used in the United States for a while when the other manufacturers for aminosin and Travasol were having manufacturing problems. We actually imported this from a company in Europe under an emergency measure that the FDA has in place. So this is the start. We prepare the base first, and I'll get back to some more details on that in a bit. Then we start putting in electrolytes and vitamins and trace elements. And lastly, we put in lipids. Lipids always go in last. TPN consists of all of these things: carbohydrate, amino acids, lipids, vitamins, minerals, and trace elements. So in this particular case, we can either have a standard, in which case we would have put all of these in. If we read down this list, NaCl is sodium chloride, NaAC is sodium acetate, KCl is potassium chloride, KPHOS is potassium phosphate, CaGLU is calcium gluconate, MagSO4 is magnesium sulfate, and then we have adult MVI, multivitamins for infusion, and multi-trace element -5. The -5 means that there are 5 trace elements in the mixture. There's also an MTE-3. In this case, we're using only the 5. Or we can specify. When it's specified, we only put in what the doctor orders. In this case, he wants 30 milliequivalents per liter of sodium chloride. Since we are putting this in a liter bag, that means that we're going to actually use 30 milliequivalents. That would be D in our calculation in a previous slide. And 15 milliequivalents potassium chloride. In this case, he's specified that there are going to be 5 milliliters per day of adult MVI. Since we are doing 2 bags per day, we're going to put half of that, or 2.5 milliliters, into the bag for each of the bags that are prepared. And the same with the multi-trace elements, 5 milliliters a day. So we're going to put in half of that, or 2.5 milliliters, into each bag. Now, these things are not actually in your drug file, so you're going to have to add them. If you look on page 107, I have given you the NDC for MVI, for adult MVI. There's also a pediatric MVI that's actually already in your system. And I've given you an NDC for the multi-trace element. And multi-trace is the trade name. But the NDC, I've given you the first 2 units, the 5 and the 4 digit units. That's all you need to actually add that to your drug database. As I said, lipids go in last. We can either specify an amount. In this case, we're using Lipocin, which is one of the lipid types, one of the lipid formulations. At 10% concentration, we're going to put in 100 milliliters. Or we can use a 20% concentration, and we can put in an amount that is specified here, such as if the doctor specified 250 milliliters every day, then half of that would go into each bag. Simple as that. So these are the way these orders are written. Okay. Let's look at the electrolyte calculations. If you look on page 8, or instruction 8 on page 106 of the lab, tells you're going to add 7.5 milliliters of potassium chloride to the solution, to the ingredients of the mixture, but it doesn't tell you anything about where that comes from. The order on page 107 calls for 15 milliequivalents per liter. As you know, that means that each bag is going to get 15 milliequivalents. Your book tells you that you're going to be using something that comes out of an ampule of potassium chloride in which the concentration is 2 milliequivalents per milliliter. That means if we look at the dV over H calculation, that means D is 15 milliequivalents, V is 1 milliliter, and H is 2 milliequivalents, because we are told that we're going to use 15 milliequivalents. That becomes D. That's read off the order. And the label tells us the concentration of drug is 2 milliequivalents per milliliter. So V is 1 milliliter, H is 2 milliequivalents. So our formula, D times V over H, now is 15 milliequivalents times 1 milliliter divided by 2 milliequivalents. Milliequivalents cancel out. That becomes 15 times 1 milliliter divided by 2. That answer now becomes 7.5 milliliters. That's where it comes from. So now, if we look at the potassium chloride, how do we know we have an ampule of potassium chloride that contains 2 milliequivalents per milliliter? Well, we have to do a drug lookup and start the search by typing POT into the name field. We get a list of products, scroll down to an injectable form of potassium chloride, okay? And we find that we're looking for an IV form. We don't want tablets, we don't want anything else. We don't want solids, and we don't want great big IV bags, but we're looking for an IV, that a small volume container that has an IV solution. So we find two of them. One, if we look at the total contents, contains 10 milliequivalents, and the other contains 20. Since we want 15, we choose the 20 milliequivalent ampule, and that ampule has 20 milliequivalents, but it's in a concentration of 2 milliequivalents per milliliter. So then when we are in our entry screen for the component, we're going to tell it 7.5 as the amount of material that we're going to use. Follow this procedure for each electrolyte to be added. For instance, you'll be adding sodium chloride at some point. You may be doing that, although that's not called for in this particular lab. You would look up sodium chloride, hunt for something that was give us a right concentration. You know, as I recall, what we have is vials or ampules containing 4 equivalents per milliliter. So in that case, you'd have 30 milliequivalents times 1 milliliter divided by 4, which again is 7.5. So we do that for each of these components. One thing to remember is that when we're putting these components together, to remember that the total of the prep is a liter to be delivered over 12 hours at 83 milliliters an hour. We add these components such that the final concentration is what's ordered by the doctor. So if the order is for 25% dextrose and 5% amino acids, we can't mix those two solutions. We can get 25% dextrose and we can get 5% amino acids, but if we mix them, we're going to be diluting them. So we have to use higher concentrations and put the right amount in to make that work. So if we were just mixing dextrose and amino acids, if we mixed equal amounts of 50% dextrose and 10% amino acids, the concentration of each would be half of what they started with. So that's how we would come up with that base. Chemotherapy. Chemotherapy is dosed by either the weight of the patient or on body surface area. The lab you're doing specifies an amount of etoposide, but if we were doing something like Cytoxan, we would be dosing by the weight of the patient. So the order might be for Cytoxan to be delivered, and the weight of the patient would have to be investigated, because Cytoxan is delivered at 40 milligrams per kilogram. And so we'd have to know the weight of the patient. So if we had a patient who weighed, say, 70 kilos, we'd have to give 2,800 milligrams of drug. We multiply milligrams per kilogram times the kilogram weight of the patient. In the case of a drug like paclitaxel or Taxol, we would be, that's dose, the recommended dose is 175 milligrams per meter squared of body surface area. So if we had a patient who was a large patient and had a 2 meter square body area, which is a calculation we won't go into here today, but we can calculate that. We'd multiply that 2 meters squared times 175 milligrams per meter square and come up with 350 milligrams of paclitaxel for the dose. So we calculate how much that would be out of whatever container it was in and add that to the appropriate IV bag as specified by the doctor. Now the assessment for this week, we're going to see a copy of it on the next slide. It's for an intravenous compounding as is done in Lab 10. The prescription is for something called MMX suspension. We're going to make 300 milliliters of it. We're going to do that by combining 100 cc's, and remember 1 cc is the same as 1 milliliter, so that'd be 100 milliliters of mycostatin suspension, 100 milliliters of Mylanta, and 100 milliliters of xylocaine. Ignore the viscous, just find the xylocaine that is a solution. You won't find mycostatin suspension, however, as such. You're going to have to look up the brand name Nystatin. And then, obviously, this is going to be given 2 teaspoons by mouth 4 times a day. Then with the additional instruction of swish and swallow. What's not listed here is it probably should be swish for 5 to 10 seconds and then swallow. The password for this assessment is Lugano, L-U-G-A-N-O. So that's what you need to enter in order to actually get the prescriptive, to get to the assessment. So I'll give you a second to write that down if you want to. So a reminder, all assignments are due by the end of the week except for the assessment, which is, ignore this, due by Wednesday before the start of class. So for you morning students, you may want to do that before midnight on Tuesday. For you evening students, you have until 6 p.m. on Wednesday. Also remember the research project PowerPoint is due by the end of the weekend for the presentation in class on Monday. So we'll be doing that. That's for all of you. And remember, if you cannot upload the assignment, email it to me. That always works. So everything is due. So that's the and remember your discussion is due by your primary post by Wednesday night, and your secondaries, your responses by the weekend. So I hope everyone has a nice Halloween or had a nice Halloween, depending on when you listen to this. I hope that everyone will be prepared for class on Wednesday. We'll be going over a lot of material. So see you then.